All right, hey folks, how we doing? This is Mr. Emmons. Just really quickly trying to demonstrate how to determine trig ratios from a point. Yes, I realize this is new, but you'll be completing this task in Delta Math, whereas I'm kind of doing it on paper, right? But I took the problems from Delta Math and generated a PDF. So I guess for each of these, we have discussed, right, an angle and standard position, angle and standard position. So what I'm going to try to do is go through a few of these, maybe not, in their entirety, but I'll do like the first part of every problem a couple times and then come back and finish. So initially, we want to sketch this angle sort of, in standard position. So they say to the point -20, 21. So it doesn't need to be exact, but -20, 21, something to that effect. So we have a point over here. The angle in standard position, what they're talking about is essentially that angle. All right, and it passes through the point -20, 21. They want to find the exact value of secant theta. All right, the question is going to be where is theta? So let's try to answer that looking at a couple more. 1, 4. Again, doesn't have to be exact or to scale. That's your angle. Let's see, what's another one look like? 12, -35. Let's see that one. Right, I'm going to say relatively, this is 12, and that would be -35. Here we go. Standard position. I'm not too concerned about. Somebody called that the squigglies. Not too concerned about the the arrow, indicating the direction in which we traveled. The important part is it goes through this point. Okay, so we've seen a few. All right, what I want to show is just like we spoke about reference angles. We said essentially we said, like, how far is it from the x-axis, right? So this is where theta is going to go in number 1. In the second quadrant, theta is going to go between the terminal side of your angle and the x-axis. All right, that's where we need to put theta. Looking at problem number 2 here, again, between the x-axis and the terminal side of your angle, that's where we need to put theta. All right, the second part we're going to do, all right, so determine where to put theta. Second thing we're going to do is create a triangle. Okay, now looking at this triangle, we then have to be able to identify the base and height, I suppose, and the hypotenuse for the triangle. Okay. The thing to stress is, I guess, keep the base. I know traditionally you would never associate a negative dimension with a length, but in this case we are going to do that. There's an exception to every rule. So we are going to label this side length as -20, right? If this point is -20, 21, -20, 21, then this base length is 20, but because we're traveling left or because we're in the second quadrant, we need to say this is -20. And then our height here is 21. You will need to use Pythagorean theorem, right? Unless this is a Pythagorean triple that I'm not familiar with, we are going to need to use the Pythagorean theorem. Oh, man. Not one I was looking forward to. This is 1, this is 4. I can then tell you square root, Pythagorean theorem, the hypotenuse will be the square root of 17. This one, if this is 12 and this is -35, again, I got to do 35 squared plus 12 squared. That's a little bit of a nightmare so to do mentally and quickly in a video. But so this one, we do know that this is square root of 17. So I'll work with this problem since, for brevity's sake. Once I find the dimensions, right? Okay, yes, Pythagorean theorem to find the hypotenuse. Pythagorean theorem to find the hypotenuse. then it's just figuring out, what ratio, what's the ratio that they desire. So this one, secant, that's the reciprocal of cosine. So I would need to do cosine the adjacent -20 over the length of the hypotenuse here, whatever radical it happens to be. Okay. And then find the reciprocal of that, and put it in simplest radical form, right? So a couple of steps there. So here they're looking for cotangent. Okay, maybe I didn't need the hypotenuse, because if this is theta, then we're just looking for, right, tangent theta is equal to the opposite, 4 over the adjacent 1. So then cotangent of theta is 1 over 4. That's the ratio that they're looking for. All right, number 2, again, Pythagorean theorem, whatever radical that is. Sine of theta, okay, fair enough. Sine of theta, opposite, -35 over whatever the length of this hypotenuse is. And I don't believe that's a Pythagorean triple. So you'll have to do 144 plus whatever 35 squared is, and then take the square root of that sum to find the length of the hypotenuse. Simplest radical form, all right? I can do this one, number 3, if you need another quick example. Okay, 7, -24. There's our point, theta. Draw our triangle. That's 7. This is -24. All right, tangent of theta. Oh, man, I was hoping this was, because, right, is this not 7, 24, 25? Is that a Pythagorean triple? Yes, it is. So I was hoping they'd ask for something else. But if this were my picture, I could then say the sine of theta is, right, opposite -24 over the hypotenuse 25. I could say the cosine of theta is adjacent side +7 over hypotenuse 25. I could figure out, yes, they're asking for a tangent, so I could figure out the tangent of theta opposite -24 over adjacent 7, and then all the reciprocals, right? Reciprocal of sine, cosecant, it'd be -25 over 24. Secant is the reciprocal of cosine, 25 over 7, and then cotangent theta, 7 over 24. All right, so I apologize for maybe not doing some of the ugly Pythagorean theorem, simplest radical form types with you, but this should be the gist of it. Plotting the point, the terminal side of the angle through it, dimensions of your triangle, the placement of theta, right, between the terminal side and the x-axis, the acute angle, and using Pythagorean theorem as necessary, and then from there just writing the ratio or ratios. So I hope that helps you complete the 6 problems of this type in Delta Math directly in the platform. All right, good luck, and thanks for watching.